Between March 23 and March 26, 1913, the Ohio River Basin received continuous precipitation across a 16,000 square mile drainage area, encompassing portions of Ohio, Indiana, and Kentucky. The region's industrial cities, Dayton, Columbus, Cincinnati, Hamilton, and Zanesville, operated under standard spring flood protocols, with levee systems designed for typical seasonal river rises. Municipal infrastructure assumed channel capacities based on historical high water marks. River forecasting networks remained rudimentary, relying on telegraph reports and local gauge stations with limited basin-wide coordination. Industrial facilities, power generation plants, and water treatment systems occupied low-lying districts adjacent to rivers and tributary confluence points. Urban development had progressively narrowed floodplains through fill operations and channel confinement structures.
The Ohio River watershed drained 204,000 square miles through a network of major tributaries, including the Miami, Scioto, Muskingum, and Wabash rivers. By 1913, the basin supported a population exceeding 5 million, concentrated in manufacturing centers processing steel, machinery, textiles, and food products. Dayton occupied the confluence of the Mad River, Stillwater River, and Miami River within a natural basin surrounded by elevated terrain. Cincinnati stretched along the Ohio River's northern bank, where the Licking River entered from Kentucky. Columbus straddled the Scioto River at a natural crossing point. These cities had constructed levee systems ranging from 8 to 15 feet in height, designed to contain flows approximating the highest recorded stages from the 1884 flood event. Channel modifications included dredging operations and wing dam installations intended to maintain navigation depths during low flow periods. On March 23rd, a low-pressure system stalled over the Ohio Valley, drawing moisture from the Gulf of Mexico into collision with cold air masses descending from Canada. Precipitation commenced as rain across the southern portions of the basin and as heavy, wet snow in northern areas. Rainfall continued without interruption for 72 hours. Columbus recorded 8.5 inches between March 24 and March 26th. Dayton measured 9.7 inches during the same period. Cincinnati gauge stations documented 6.3 inches. Temperatures rose above freezing on March 25th, converting accumulated snowpack into runoff. Soil moisture levels from winter snowmelt had already saturated the upper layers of the watershed. Ground infiltration capacity diminished, directing precipitation directly into tributary systems. Stream flow monitoring stations recorded discharge rates exceeding any previous measurements in their operational histories. The uniformity of precipitation distribution across the entire basin eliminated the typical temporal offset between tributary peak flows. By March 24, tributary rivers throughout the basin began simultaneous rises. The Miami River at Dayton increased from a normal stage of 3 feet to 12 feet within 18 hours. The Scioto River at Columbus rose from 4 feet to 18 feet in the same interval. The Muskingum River at Zanesville exceeded its banks by the evening of March 24. The confluence timing of these tributary systems eliminated the natural flood attenuation that typically occurred when peak flows arrived sequentially at main stem rivers. The Miami River's 3 forks, the Mad River, Stillwater River, and main stem, converged on Dayton within a 6-hour window on March 25. The Ohio River at Cincinnati received simultaneous flood pulses from the Great Miami, Little Miami, Licking, and Kentucky rivers. River stage gauges recorded rates of rise between 2 and 4 feet per hour at multiple locations. Hydraulic modeling capacity did not exist to predict the compounding effect of synchronized tributary peaks. Dayton's central business district submerged under 8 to 12 feet of water by midday March 25th. The industrial district south of the Great Miami River experienced depths reaching 20 feet. An estimated 65,000 residents, representing 60% of the city's population, occupied areas inundated above ground floor levels.
In Cincinnati, floodwaters reached 10 blocks inland from the Ohio River, submerging the Mill Creek Valley Industrial Corridor under 12 to 15 feet of water. Columbus experienced inundation across 2,500 acres of the west side, with depths ranging from 4 to 14 feet. Hamilton reported 75% of its built area underwater. Zanesville's downtown district received 8 to 10 feet of flooding from the Muskingum River. Terre Haute, Indiana, on the Wabash River, recorded similar inundation patterns. The synchronized timing eliminated the possibility of resource redistribution between affected cities.
Electric power generation facilities ceased operation as floodwaters reached boiler rooms and turbine floors. Dayton lost all electrical service by 10 a.m. on March 25th. Water treatment plants stopped functioning when intake structures submerged and pumping stations flooded. Municipal water pressure dropped to 0 across affected districts. Natural gas distribution networks experienced main breaks and valve chamber flooding, requiring system-wide shutdowns. Telephone and telegraph connectivity failed as exchange buildings lost power and cable vaults filled with water. Railroad operations halted when track sections submerged and bridge approaches washed out. The Cincinnati Southern Railway lost 40 miles of main line to erosion and debris accumulation. Streetcar systems became inoperable. Road networks transformed into debris fields, with floodwaters depositing industrial materials, damaged structures, and household goods across transportation corridors. Emergency coordination operated without functional communication infrastructure. Fire departments could not respond to ignition events in buildings with ruptured gas lines. Police services lost contact with precinct stations. Hospitals treating flood-related injuries operated on emergency lighting until fuel supplies for backup generators depleted. Evacuation directives could not reach populations in isolated sections of cities. Rescue operations relied on privately owned boats and improvised watercraft. No regional command structure existed to allocate resources between municipalities experiencing simultaneous crises. State militia units required 24 to 48 hours to mobilize and reach affected areas due to disrupted rail service. The Ohio National Guard deployed 5,000 troops by March 27th, 3 days after initial levee failures. Federal government response consisted of emergency appropriations approved on March 28th, with no operational disaster relief mechanism in place. The flood event affected approximately 1.5 million people across the Ohio River Basin. Death toll estimates ranged from 360 to 467, with variance attributable to incomplete reporting from smaller municipalities. Dayton recorded 123 confirmed fatalities. Columbus documented 93 deaths. Hamilton reported 81 casualties. Additional deaths occurred in Peru, Indiana, 70, and across smaller communities throughout the basin. Injury figures exceeded 10,000, primarily consisting of trauma from debris impact, hypothermia, and contaminated water ingestion. Approximately 250,000 people displaced from residences required emergency shelter. Property damage assessments totaled $147 million in 1913 currency values, equivalent to approximately $4.2 billion adjusted for inflation to 2023. Industrial facilities sustained equipment losses and inventory destruction. Agricultural lands received silt deposits and debris fields requiring months of clearance operations. Floodwaters receded beginning March 28th as precipitation ceased and tributary flows returned to channels. River stages dropped below levee heights by March 30 in most locations. Debris removal operations began immediately, employing manual labor crews and horse-drawn equipment. Disease prevention efforts included typhoid vaccination campaigns and water supply disinfection protocols. Temporary shelter facilities operated for 6 to 8 weeks. The Miami Conservancy District, formed in Dayton through legislation passed in June 1913, authorized to construct a system of 5 detention basins upstream of the city. Engineering surveys commenced for similar flood control projects in Columbus, Hamilton, and other affected municipalities. The U.S. Army Corps of Engineers initiated comprehensive river flow studies across the Ohio Basin. Federal legislation creating systematic flood control authority did not pass until the Flood Control Act of 1936. The Ohio River Basin floods of March 1913 established maximum recorded river stages that remained unexceeded for multiple decades. The Miami River at Dayton crested at 29.0 feet, a record that stood until 1959.
Hydrological analysis determined the event represented a 500-year recurrence interval flood from multiple tributary systems occurring simultaneously. The Miami Conservancy District completed its 5-dam system between 1918 and 1922, creating 143,000 acre-feet of storage capacity. Similar conservancy districts formed in the Muskingum River watershed and other Ohio tributaries. The 1913 flood became the baseline event for subsequent flood control design standards. River forecasting networks expanded through the 1920s and 1930s. Basin-wide rainfall monitoring systems gradually replaced localized gauge networks. The event demonstrated the vulnerability of urban areas located at tributary confluences and the limitations of levee-only flood protection strategies.